Welcome, everyone. We're very happy to be one of the first session of a Spark Summit. So in this talk, we're going to give you our best practices and pitfalls that we learned while running Spark on top of Kubernetes. So first, a few words about who we are. We're JY and Julien, the co-founders of Data Mechanics, a Y Combinator-backed startup building a very easy-to-use Spark platform. I'm JY. I previously worked as a software engineer and Spark infrastructure lead at Databricks. And Julien, our CTO, previously worked as a data scientist and data engineer at Content Square and BlaBlaCar. So I have more expertise with Spark on the infrastructure side, and Julien has expertise with Spark as a user on the application side. So now that we told who we are, I'd like to do a quick live poll. So as you know, the session is pre-recorded, so I won't know the results here. If I had to take a guess, I'd say that the majority of you never use Spark on Kubernetes, but we look forward to seeing the results. Maybe we'll be surprised. And by the way, even though the talk is recorded, we'll be here on the chat with you in live to answer your questions. So feel free to make this as interactive as possible. Great, so here's how we'd like to spend the next 25 minutes with you. I'll first say a quick few words on data mechanics to give a bit of background on our usage of Spark and Spark on Kubernetes in particular. And then we'll get to the meat of the presentation. First, the core concepts of Spark on Kubernetes. Then we'll go over a wide range of configuration and performance tips. We'll go over best practices for monitoring and security. And we'll talk a bit about the future works that are being worked on in open source. So first, data mechanics. We are a serverless Spark platform. What does that mean? We provide a serverless experience to data scientists and data engineers so they can focus on their application rather than the infrastructure. So how do we do this? We're containerized, meaning applications start and scale quickly to speed up your iteration cycle. Then we integrate with the tools that you already use, Jupyter Notebooks, your IDE, Airflow, and we make the transition from your local development, your existing workflow to running on data mechanics seamless. And finally, our platform tunes the infrastructure parameters and Spark configurations automatically for each pipeline. For example, we tune the amount of memory and CPU to allocate to each Spark worker. We tune the default parallelism, the number of partitions, the shuffle configs, the instance types, and so on. So this automated tuning has a massive impact on stability and performance. On the stability side, we can avoid or automatically remediate many errors, say out of memory, for example. On the performance side, we can fix parallelization issues, over provisioning, bad shuffles, optimize the I/O. On average, we've been able to get a 2x performance boost, meaning faster pipelines and lower costs. So if you have any questions about how this works, check out our presentation from last year at Spark Summit Europe. And now I'll move on to a topic that's more relevant for today's talk, our architecture. So our platform is deployed on a Kubernetes cluster in our customer's cloud account. This is very important for security and data privacy reasons. You know, our customers' sensitive data never leaves their account. The Kubernetes cluster auto-scales up and down. At the minimum, there's just one service running, our gateway, which is the entry point for launching Spark applications. So you can point a Jupyter Notebook to it, or you can submit apps programmatically through Airflow, another scheduler, or the API. The gateway will take your app, add configurations, it will scale it, and give you access to a monitoring dashboard. So we built our entire product on top of Spark on Kubernetes, which is why we had the pleasure to learn some of its tricks that we'd like to share with you now. So first, the core concepts of Kubernetes. Where does Kubernetes fit within Spark? Kubernetes is a new cluster manager or scheduler for Spark. Previously, you had the standalone scheduler, which is built in but has limited features. You have the Apache Mesos, which was popular but has been some decline over the last few years. And then there is Yarn, which is by far the most popular resource manager, which is the Hadoop resource manager. And basically, many platforms run on Yarn, like EMR, Dataproc, Kubel, HD Insight, etc. Kubernetes is definitely the new cool kid on the block. Spark can natively run on Kubernetes since version 2.3. So here's a slide that shows the architecture of this native support. When you submit a Spark application, you talk directly to Kubernetes, the API server, which will schedule the driver pod, so the Spark driver container. And then the Spark driver and the Kubernetes cluster will talk to each other to request and launch Spark executors. This can happen statically, or this can happen dynamically if you enable dynamic allocation. So like driver pod asks for executors, Kubernetes starts them, tells the driver pod, and then the driver is going to start using these executors to run the Spark tasks. There are two ways to submit Spark application on Kubernetes. You can use Spark Submit, which is the vanilla way, part of the Spark open source project. However, app management is pretty manual. We'll see this on the next slide. And there are some configuration limitations. For example, you can't specify node selectors or affinities. Now, the second way is the Spark on Kubernetes operator. It's been open sourced by Google, and it works on top of any platform. On the negative side, it needs a long-running system pod, so it needs to run a small container on the Kubernetes cluster. But app management is simpler, and you get a lot of tooling for free to read logs, kill application, restart them. So this would actually be our recommendation. As you can see, on the left side, this is how you do a Spark Submit. And after the Spark Submit, the only way to interact with your app is by doing Kubernetes operation on the pod. It's not very powerful. Now, on the right side, you'll see that with the operator, a Spark application becomes a Kubernetes object that you can configure in YAML, describe, delete, restart, etc. So the last core concept I want to explain is around dependency management and containerization. On Yarn, you often have a shared Spark clusters where you run multiple apps concurrently. Usually you do this for cost reasons, but then you have to trade off on isolation. You must have a global Spark version, a global Python version, and global dependencies that can clash against each other. So another common issue is the lack of reproducibility. You must run init scripts that can be flaky, or you're not entirely sure of the environment. Sometimes there's a global system changes on the cluster that can affect your app. Now, in Kubernetes, on the other hand, each Spark app has its own Docker image. This means you can have full isolation and full control of your environment. You pick your Spark version, your Python version, your dependencies. Some of our customers use Docker to package all their dependencies and build a new image for each app. And others prefer to use a small set of base images, and then in this base image, they put their more heavy common libraries, and then they just add their execution code dynamically on top. So I'll now pass it over to Julien, our CTO, who will give you concrete configuration and performance tips to make you successful with Spark on Kubernetes.
Thanks, JY. I will now give you some tips to get you up and running faster with Spark on Kubernetes and reach the level of performance that you're used to with other schedulers like Yarn and Spark standalone. The first surprise when you run a workload on Kube is that you cannot just size executors to fit the size of your nodes. Suppose I have a cluster with 4 core instances. If I set the number of cores per executor to 4, the Spark driver will never obtain many executor pods. And a similar thing happens with memory. What's the reason? Well, you need to take into account the share of resources that is reserved by the system and by Kubernetes. The full node capacity for cores is not available to pods. What is available is called node allocatable, and it's usually around 90 to 95% of node capacity. It depends on the size of your node and the Kubernetes settings by the cloud provider. And even that is actually not available to your executor pods, as you usually have some daemon sets running like fluentd or something. So eventually, in my example, you only have 85% of the node that is available to your Spark executor pod. So the correct configuration is set Spark executor cores to 4, so that Spark runs 4 tasks in parallel on a given node, but set Spark Kubernetes executor request cores to 3.4 CPUs, so that the pod is actually scheduled and created. The next tips that we want to share are about dynamic allocation. On Yarn, you can enable an external shuffle service and then safely enable dynamic allocation without the risk of losing shuffle files when downscaling. On Kubernetes, the exact same architecture is not possible, but there's ongoing work to work around this limitation. In the meantime, a soft dynamic allocation is available in Spark 3.0. The Spark driver tracks shuffle files and only allows the eviction of those executors that do not store active shuffle files. This works great in practice, though on average, the scale down of Spark applications is slower compared to a full-fledged dynamic allocation. One cool setup that you can do with Spark on Kubernetes is having Spark applications with dynamic allocation activated and autoscaling on the cluster. So when the Spark application requests a new executor, it takes a few seconds to create a new pod if there's room on the cluster. But if there isn't, the cluster will scale up, and it usually takes 1 or 2 minutes to get a new node from the cloud provider. This in practice is a major cost saver. On the other hand, if you're willing to trade off some cost optimization for lower latency, you can reserve some extra resource in your kube cluster with over provisioning. The idea is to run some low priority pods that basically do nothing. They're called pause pods, and when a Spark application is run, the pause pods will be killed to make room for the Spark executors, and then the pause pods will be scheduled again and cause the cluster to scale up in the background. If you want to go further in cost reduction, you can also use a spot or preemptible instances. Just make sure to run the Spark driver on demand nodes and Spark executors only on spot instances. The reason is, if the node of the driver is preempted, the Spark application will fail. This is easy to do on Kubernetes with several node pools, and you can assign node affinities to pods so that they're preferably scheduled on nodes from specific node pools. Now a few tricks about performance. Most of you know about this, I'm sure. An object storage like S3 or GCS does not behave like HDFS. The latency of doing an operation on a single file is huge. So it's important to use a file output committer that minimizes the number of operations. Some cloud providers write optimized committers for their object storage. So make sure to use them if it's available to you. If it's not the case, on your cloud provider, just use the version 2 of the Hadoop committer that's bundled with Spark. It works pretty well in practice too. Shuffle. If you have the shuffle-bound workload and just run it by default, you'll realize that the performance of Spark on Kubernetes is worse than Yarn. The reason is that Spark uses local temporary files during the shuffle phase, and this causes lots of disk I/O. And unfortunately, Docker file system is slow. To solve this issue, you can mount volumes in the executor pods so that the file system is faster. There's a variety of options that you can use here. The basic solution is to mount an empty dir. An empty dir is a temporary folder in the host file system that can be used by the pod. It's implemented by default in Spark 3.0. Then if you have mounted fast disks on your node, like NVMe-based SSDs, you can mount a host path. It's like an empty dir, but you can specify the path on the host machine file system. And in our case, you can set the host path to the location of the mounted disk. And finally, you can use RAM as a local storage with a protocol like TMPFS. This is super fast, but the stored files will count toward your memory limit. So be careful with this solution. Spark performance is a hard topic, as you all know, and the few tips we shared go to show that it requires some knowledge of the nature of your workloads. Is it CPU bound, IO bound, and so on? So you need a good monitoring infrastructure, and we're going to see some ways to do this on the Kubernetes cluster. The first type of monitoring to set up is pod resource usage monitoring. The Kubernetes dashboard is an open source project that you can install and that reports CPU, memory, and disk usage in a web UI. The GKE console, if you're on GCP, provides a pod resource usage as well. The main issues, though, with this type of monitoring are first, that it's hard to link with Spark phases like jobs, stages, and tasks. And second, executor pods are removed once the Spark app is finished. And so you lose a lot of useful metadata. Another classic of Spark fine-tuning is the Spark history server. It's relatively easy to set up with the Spark history server Helm chart. But again, the main issue with the history server is the reciprocal of the Kube dashboard. It lacks resource usage metrics. So here's a way to link Spark events and resource usage metrics. What you can do is export everything to a Timeseries DB. This enables the superposition of Spark stage boundaries and resource usage metrics, like what you can see on the Grafana dashboard on the right of the slide. I won't go into detail here, as there's a great talk on this very topic at last year's Spark Summit by Luca Canale. One last word for me about security. This is an area where Spark can leverage the fact that it's running on Kubernetes. Kubernetes has a strong built-in role-based access control model and secrets management, and there's a plethora of open source projects that you can plug in to make your life easier, like Istio or HashiCorp Vault. So in a nutshell, Spark really benefits from all the latest DevSecOps advancements for free, just by running Kubernetes. I'll now pass it over back to JY, who will talk about the ongoing work on Spark on Kubernetes.
Great, thanks, Julien. So yeah, the next topic I want to discuss is the features that are really being worked on right now for Spark on Kubernetes that we expect to come out in Spark 3.1 and beyond. First, the shuffle improvements. Julien touched on this a little bit. On Yarn, there's a thing called the external shuffle service, which, when enabled, stores shuffle data outside of the Spark executor, but still on the Yarn cluster. The goal with Spark on Kubernetes is to persist shuffle files to a remote storage outside of the cluster, probably an object store, and maybe asynchronously to avoid a performance penalty. The goal to disaggregate the compute and the storage resources is to enable the full unconstrained dynamic allocation, and it would also make Spark resilient to node loss, which is not the case of the Yarn external shuffle service. Now, another resiliency improvement in the works is around better handling for node shutdowns. So now cloud providers give you a notice a few minutes before a spot or preemptible node is going away. Today, when we receive this notice, we stop scheduling tasks on the impacted executors, which is already great, and this is implemented. But now the next improvement is to use this remaining time to live to copy any shuffle data or any cache data to another node so that you don't lose it. Other works being worked on is support for local Python dependency upload when using Spark Submit, and also the general topic of job queues and improved resource management, which I won't go into the detail now. So to conclude, Spark on Kubernetes, should you get started, is it worth it? Know that we are obviously biased in this answer since we chose to build an entire platform around Spark on Kubernetes. We think it's the future of Spark. The main benefits we see are containerization and the simpler dependency management. Second, the integration in the rich Kubernetes ecosystem. And finally, the fact that you get both complete isolation and efficient resource sharing when you use Spark on Kubernetes. You don't need to trade off between the two. On the negative side, Kubernetes support is still pretty new. It's still marked as experimental until version 2.4. And there's also a lot to learn and a lot to set up yourself as you get started. So to illustrate this point, here's a high-level checklist of things you should do if you want to work with Spark on Kubernetes. On the infrastructure side, you need to set up the Kubernetes cluster itself, the Spark operator, a Docker registry, the Spark history server, some monitoring for your logs and metrics. And then on the configuration side, you need to configure node pools, configure or optimize I/O, configure autoscaling, maybe spot nodes or on-demand nodes. And this is not a one-time thing, but probably something you'll need to revisit to keep watch on your performance. And that's a lot of work, and that's really the reason why we built a serverless Spark platform. We've done the setup work and data mechanics, and we added powerful optimizations on top, like automated tuning, so that you can focus on your core business, building data models and data pipelines, rather than the DevOps work. Focus on your data while we handle the mechanics. So that's it. We hope you enjoyed the talk. We're available in the chat to answer any questions you might have. Thank you very much.